All right, this is part 2 of section 1.4. We are going to now graph our transformations. So let's list my transformations first. F of x equals x cubed minus 2. Well, my parent function is y equals x cubed. And I just have a minus 2 down, or sorry, minus 2 on the end, so it's a shift down of 2. So I'm going to draw myself in yellow here, a light sketch of y equals x cubed. Oh, okay, I can only fit a couple of points apparently. That's the basic idea of what it looks like. Then I shift everything down 2. Ooh. Almost made it where I could graph another point. And there we go. All right, g of x equals negative x plus 4 squared minus 1. First off, my parent function is y equals x squared. All right, I have a negative out front. That's a reflection over the x-axis. I have a plus 4 in with the x, which is a shift left 4, and a minus 1 on the end, which is a shift down 1. So starting with my original graph, y equals x squared is a parabola. All right, there's my original graph. First, let's reflect over the x-axis. So I'm actually going to use a couple different colors. If I reflect over the x-axis, that means every point, if it's a positive y value, it becomes a negative. And if it were a negative y value, it would become positive. So now my graph looks something like that. Then I shift left 4 and down 1. I'm just going to take these couple points I made and shift each one left 4 and down 1. And there's my graph. All right, h of x here. I start off with the parent function. My parent function here is y equals 1 over x. Stretches and shrinks. I have a 2 out front. That is a vertical stretch by a factor of 2. No reflections. I have a minus 1 in with the x, so that is a shift right of 1. And a plus 3 on the end, which is a shift up of 3. Now graphing this one's a little wonkier because the only really good points we have are 1, 1, and negative 1, negative 1. So when we do this, we are going to start with our vertical stretch, which means 1, 1 becomes 1, 2. Negative 1 becomes negative 1, negative 2. Now you have to think about 2 a half, right? If x was 2 in my parent function, y was a half. If I double that, it becomes 1. So I really have negative 2, negative 1 as well. So now I can kind of draw my sketch a little bit. Oops, I don't want arrows yet. Okay. Then we're going to shift right 1, up 3. So I'll just take those 2 points, go right 1, up 3, right 1, up 3, right 1, up 3, right 1, up 3. And then follow what that graph should look like. And there's my new graph. All right. Here we're going to say a graph of f of x, given the transformations, we are going to graph it. So this is just f of x. It's nothing special. It's a random piecewise function. My function here, I have a 3 out front, which is a vertical stretch by a factor of 3. And then I have a plus 1 in with the x, which means it is a shift left by 1. So here's how we're going to do this. We'll take a point. This point is -2, -4. A vertical stretch of 3 means that this y value is going to get multiplied by 3. So it's going to become -2, -12. That goes slightly off my graph. Okay. 0, 0. Well, multiply my y value by 3, it's still 0, 0. 2, 2. Multiply my y value, because it's vertical, by 3, which makes 2, 6. And then 4, 0. Multiply the y value by 3, it's still 4, 0. So right now, my function looks something like that. Now let's shift everything left 1. I'll just take those 4 points I just made and shift them left 1. And there's my new transformed graph. All right, same graph to start. Slightly different function. All right, stretches and shrinks. I have a 2 out front. That is a vertical stretch by a factor of 2. I also have a negative out front, which makes it a reflection over the x-axis. We have a -3 in with the x, which is shift to the right 3. And on the very end, we have a -1, which is a shift down 1. You may notice I'm trying to color code this one, and I put the shifts both in the same color because I can do them at the same time. Let's start with our vertical stretch by a factor of 2. So we're going to take our points. Notice they're the same points as before, but they are -2, -4, 0, 0, 2, 2, 4, 0. Vertical stretch by a factor of 2 means multiply my y values by 2. I get -2, -8. 0, 0 still, 2, 4, and 4, 0. Oops, pretend that was straight. There's my first transformation. Then I reflect over the x-axis. So the point -2, -8 becomes -2, +8. 0, 0 stays where it was. 2, 4 becomes 2, -4. And 4, 0 stays where it was. And then we'll take those 4 points and shift each of them right 3 and down 1. And connect them as best we can with all the other craziness we have going on that graph. All right, so this time we are going to find a parent function that makes the solid line and determine one single transformation to make the dotted line. Well, the solid line is my parent function, y equals 1 over x. So a single transformation to switch it to this dotted line, you actually have 2 options. You could reflect over either axis on this one. Reflect over, I like the x-axis better. Reflect over the x-axis. So that means my new function is y equals -1 over x. All right, the second one here. My parent function is x squared. So y equals x squared. A single transformation. Well, this function is either skinnier or taller, depending which way you want to think about it. I personally like to think of it as taller. So the point 1, 1 is actually at 1, 2. And 2, 4 is at 2, 8. My y values are all doubled, which means it's a vertical stretch. Oops. By a factor of 2. So my function would be y equals 2x squared. All right, this one, my solid line. My parent function is y equals the cube root of x. A single transformation, well, it looks like I just suited it up 4. So I shift up 4. And to write that in my function, I just put a plus 4 outside on the end. And now we're just going to describe some similarities and differences. Similarities here. You notice they have the same basic shape. You'll notice the ends do the same thing. The left goes down, the right goes up. So left down, right up. There's only one x-intercept. It's always increasing. It's got a domain of all real numbers or range of all real numbers. A lot of similarities. Now let's look at differences. They have different x-intercepts. They also would have different y-intercepts because we can't even see this one's y-intercept because it's going to be way up high. Well, there's that one's right there. And obviously the actual values of the function are different. But other than that, they have more in common than they do different because all we did was shift it. All right.